Hey, how's it going, everyone? Looks like we have some people in here already. Looks like there's 6 of you here. We will give it a few minutes for everybody to kind of get logged on, but we are going with 5.1 or 5.3 today. If you don't mind, say something in the chat just so I can see who's here. Just say hey or thumbs up or something like that. Got 2 of you. Who is BES? Good to have you, Bernice, Caitlin, Kristen, Josiah, Abby. Can you all hear me loud and clear? Does the visual look okay? Do you see everything looks all right? Somebody can answer that. Abby, does everything sound good? Give these guys a few more minutes. Hey, if you're just logging in, just say like hey in the chat box just so we see that you're here. So here is who I have thus far. Abby, Josiah, Bernice, Caitlin, Lizzie. Who is Lizzie? I'm just kidding. That's Lucy. Abby, Maddie, Christina. Christina, what's that on your lap? What's that Flora? Elena. Dang, Twitch got on here. Elena, aka Twitch. Yeah, get your calculators. There's Elizabeth Woods in the house. Dom's in the house. Okay. Kelsey's here. Man, I think everybody's here. Kristen. Sebastian's here. He said he's here. He just can't type anything. Look at us, man. Oh, yeah, sorry. Elena got the nickname Twitch. No, is it Twitch? Hold on. Yes, it's Twitch. Off the movie Holes. She kind of looks like him, and she's always kind of twitching like him, so that's why. Here's a picture of Twitch. If you've never seen Twitch before, so he's the one that sells cars. So maybe that's her. Not sure. All right, a couple of things, guys. You want to make sure. I can't really show this on the video, but you want to make sure that you're always on the live. Okay, always make sure. So, like, if you're watching a video, like if here's the pause button, there's a bar running down here like this. You're going to want to make sure this little dot is all the way down here. Okay, and that's when you're at live. That's when you're on the live with us. If you see like you're way behind, that means your dot could be right here, and you just need to drag it up here. Looks something like that. Okay. All right, so let's go ahead and get started with lesson 5.3, notes and lecture. Okay, so before we went on our ACT and everything, we went 5.1 and 5.2, which was over exponents and doing operating with exponents, knowing the difference between radical form and not radical form. So today we will kind of continue in this. Looking at number 1, it's just graphing radical functions. It says identify the domain and range of each, then sketch the graph. All right. So what we're actually going to do is we are actually going to create a new parent function. And that parent function is absolute value of x. Now, we know x squared to be a parabola. We know x cubed to be a snake, per se. We know absolute value of x is the v. We know, let me straighten my camera out just a little bit. We know that 1 over x looks something like this. Or it's actually the other way, but we kind of understand that. And then today we'll create 2 more, the absolute value of x. And I didn't mean the absolute value of x, the square root of x and the cube root of x. Okay? So just like we started with all of those type problems, we started with a x, y table. So here we have a x, y table. Someone type in something that in the chat box. We'll do this a lot. Someone type in something in the chat box that I'd want to put in for x. Just someone shoot something in. A 3. I would not want to do a 3. A 0. Okay, yeah, cool. Let's start with 0. I see that's Christina. So let's start with 0. So if I put a 0 into the square root of x, what is the square root of 0? So that's like saying this. What is the square root of 0? Square root of 0 is 0. So when x is 0, y is 0. Abby said 1. If I plug in, what's the square root of 1? 1. All right. And then I see Elizabeth is saying 4. What's the square root of 4? 2, right? And then I don't think, let's go ahead and do 9 as well. What's the square root of 9 is equal to 3, right? So we've created this XY table here. And with this XY table, let's now create the points in the graph. 0, 0, 1, 1, 4, 2, and 9, 3. Now, I saw where Caitlin Gibson said, what about -1? So what is the absolute value of -1? Type that into the chat box. Sorry about that. Type that. What is the absolute value of -1? Type it into the chat box. Very good, Christina. Very good, Abby. Elena, you need to learn how to type. Some of you getting it right. Some of you maybe thinking about something. But if you remember, the square root of -1 is I. Yeah? So, how can I graph -1i? Keep in mind, 1i, is an imaginary number. So it is not on the graph anywhere. So therefore, I cannot graph that. So that creates what we would consider a restriction. Okay? So we're going to type out a little note here, or write out a little note here. Sorry. A square root can never be negative. Example, -1. So this is what we would call a restriction. This can't happen. All right. What is another restriction we just went over? Can someone type that in? What is another restriction we've just gone over in math? What something cannot be? Very good, Maddie. The denominator cannot be 0. And hey, Josiah, very good as well. He said having a radical in the denominator, that's not much as a restriction as it is just a simplification process. Okay, that's more of a simplification process. But what we're looking for is the denominator cannot be 0. So really, you have two things that restrict functions. Okay, two restrictions for the most part, and those two restrictions are one, denominator cannot be 0. And then their second one is you cannot have a negative square root. Give me a thumbs up, a smiley face, something if you're kind of following along with that. Thank you, Caitlin. Thank you, Abby. Thank you, Maddie. Thank you, Christina. Good, Elena. Good, Josiah. Lucy, good. Bernice, good. Dom, good. Kristen, good. Elizabeth, good. Okay. Hey, and anytime you have questions, just throw it out there into that chat. Okay, throw it in that chat. I'll answer them as we go along. Okay, so here we go. So now going back to my graph. Now going back to the graph, I'll finish this graph. So it looks something like this. Okay. So now let's identify the domain and the range. So my domain, who could type the domain into my into the chat box using the correct interval notation? And you might have to spell out a symbol. So Christina said 0 to infinity. Maddie said 0 to infinity. Okay. There, and I don't know if Maddie just couldn't find the right thing on there, so we won't hound her too much. But this is 0 a part of the domain? It is. Okay. So we're going to say the domain again. What is domain? Domain is the possible x values. Okay. So it's from 0, and we put a bracket on there because it is included. It's a part of the domain, and then it goes from there all the way to infinity, and infinity would have a parenthesis on it. Okay. So it's negative. The reason that it's not negative is because negative is imaginary. Okay, and it would never work on the graph because imaginary does not exist, but the graph is only real numbers. Okay. All right, let's look at 2. So 2, y equals the cube root of x. All right. So as we did here, let's start with an xy table. Oh, good call, Elena. Thank you. That's why you're here, Twitch. All right, so now let's talk about the range. Sorry. So let's talk about the range. Now, what is the range? The range are the possible y values. So can someone type the range into the chat box? What is the range? There we go. Yeah, very good. It's the range here is actually the same as the domain, 0 to infinity. What other parent function have we determined? Which one of these up here has where the domain and the range is the same? Which one? Abby says x, assume that's x squared. Josiah says x squared. Bernice says absolute value. Lucy says absolute value. And everybody's going crazy. Everyone's going crazy. The correct answer, due to we having a bunch of different answers, your answer would be x raised to the third power. Okay, x cubed. And make sure, and when you're using the when you're trying to show an exponent, just hit the caret top, which is just the number 6 here. Okay, so and the reason it is because if you think about x squared, sorry about that. If you think about x squared, the domain is negative infinity to infinity, but the range does not go all the way down. Here, x cubed is the only one where the domain and range is negative infinity to infinity. Absolute value, the range is restricted. Here, obviously, the range is restricted. So therefore, with the absolute, or excuse me, not the absolute value, the square root of x, the domain and range would also be the same there. Okay, very good. So now we can kind of say we kind of have the graph for x, the square root of x, which would just simply be just going to the right. Okay, so I answered the questions. We sketched the graph. We should be good there. Now let's go to number 3. So as we're starting with number 3, just like we started with number 2, what we want to do first is we want to create an XY table of the graph. So let's create an XY. So I have X, I have Y. Okay, so talking to, let's go with you, Kelsey. Kelsey, what would give me a number that I probably should put in for X for here? Is Kelsey still with us? Caitlin, that's the letter O, not 0. Just helping you out. Okay, so let's go with, since all of you are like blowing it up, let's go with 0. What's the cube root of 0? Cube root of 0 is 0. Cube root of 1 is 1. So we have 0, 0. We have 1, 1. And somebody else said the cube root of 8, the perfect cube after 1 would be 8. The cube root of 8 is 2. So 8 and 2. Now, so that gives us that. Now, notice in our restriction up here, notice what we said. You cannot have a negative square root, but we did not say anything about a negative cube root, because can I have a negative inside a cube root? Yes, because something can multiply by itself 3 times to give us a negative number. Okay, so now let's just include the negatives here. What is the cube root of negative 1? So really what we're asking is, really what we're just asking there is what's negative 1 times negative 1 times negative 1, and that would give us negative 1. And then same thing with negative 8. What times itself will give us negative 8? Negative 2 times negative 2 is positive 4, but times another negative 2 would give us a negative 8. So that would be negative 2. So I have negative 1, negative 1, negative 8, negative 2. Should be looking something like that. And then obviously from here, we're just going to go up, come around. We could say this looks very similar to x cubed turned sideways. So from there, let's identify the domain. All right, Elena, what is the domain? I'm asking Elena. Okay, Elena, very good. Negative infinity to infinity. Very good. It represents all x values there. And then Kristen, how about the range? What would my range be? Kristen. Good, Kristen. Negative infinity to infinity. Okay, so if we were to go back up here to our list of parent functions that we learned thus far this year, we've just added another one. In that we know that that right there is that. And you may see some similarity between the square root of x and, the cube root of x and x squared and x cubed. Abby, when you say, will these always be the same, what do you mean by that? Yes. Yes. Sounds good, Kelsey. Okay. Now, who can give me a how can I rewrite the cube root of x? Anybody? Sorry about that. How can I rewrite the cube root of x? Very good, Elizabeth. Elizabeth was kind of catching on where I was going. The cube root of x can be rewritten as x raised to the 1/3 power, and the square root of x can be raised to x to the 1/2 power. So if you were to look on your calculator, if you were to look up there and you were to see like x to the 1/2, which is the same as square root of x, and you were to graph that, you get the graph as shown. What we found for number 1. If you graph x to the 1/3, you're going to get the graph as we've seen it on the second one. Okay. So changes a little bit, okay, but we know we can kind of see that the and you some of you may be able to kind of spot out some similarities between x to the 1/3 and x cubed, and x squared and x to the 1/2. I wouldn't say horizontal compression, maybe more of a rotation, but not compression. Deals with pushing it down. So, but I definitely could see if x squared looks like this, we've really just rotated it, right? And then same thing with x cubed. If x cubed does this, if x cubed does this, and then it looks like it's just been really rotated a little bit. So, but no, good, good point. Maddie, they're the same, so it doesn't matter. Both of them are, most of the time you're just going to see it in the form of the square root of x and the cube root of x. Yeah, so you may see them. I mean, they're the same thing. So, but generally you're going to see it as the parent function looking like this. I don't see too much of the cubing function, but I see a lot of the square root of x function, just because it has some restrictions. All right, give me a thumbs up if you're good with 1 and 2 and everything we discussed there. Thumbs up, smiley face, something like that. Thank you, Maddie, Abby, Caitlin, Elizabeth, Lucy, Bernice. Thank you. Thank you, Christina, Dom, Josiah. Is Twitch still here? Hey! All right. Going on to number 3. So basically our goal is just graphing radical functions. That's what this whole lesson is about, is just simply graphing them. Okay? So having the ability to graph them. So let's look at number 3. Now, you all probably know a little bit about this. So can someone even begin to throw a guess out of what I would do with this from the parent function? Actually, no, let me be more specific. Not anybody. Let's go with you, Abby McDonald. Do you have a guess of like what this -3 and this +4 would do to the parent function, the square root of x? Behind Abby would be Christina. Christina, how about it? No, you're cool, Abby. Don't worry about it. Christina, do you know what we might possibly do with that -3 and the +4? Okay, so good guess. 4 would be the y-intercept is what she's thinking. All right, that's not a bad guess. So here's what I want. Yeah, so let's talk about this real quick. If I didn't know how to do this shorthand, what would I make in order to graph this function? If I did not know how to graph this just off the top of my head, what would I make? Thank you, Elizabeth. XY table. Okay. So let's make an XY table for it. So making an XY table, I need values in here that's going to make it easy on me for my table. So give me a value, Bernice. What would a value be? Okay, so Bernice said 12. So if I put a 12 in there, I get 12 minus 3, which is 9, right? So the square root of 9 minus 3 plus 4. So that would, or excuse me, 12 minus 3. She said 12, not 9. So 12 minus 3 is the square root of 9 plus 4, which is what? 3 plus 4, which is, sorry about that, 3 plus 4, which is 7. So when x is 12, y is 7. All right. Not bad, but I just need to probably find something more on the number line. Correct, Elaine. Correct, Maddie. The 4 does not go with the 3. If it did, it would extend out. Okay. What is another number? Okay, good. Okay, I'm seeing that, Caitlin. Yeah, so let's look at a 4. So if I plug in a 4, 4 minus 3 plus 4. So if I plug in a 4, 4 minus 3 is radical 1 plus 4. And that would be 1 plus 4, which is 5. So when x is 4, y is 5. So I can put a point there, 4, 5. Maddie says 7. I agree with 7. 7 minus 3 plus 4. That would be radical 4 plus 4, which is 2 plus 4, which is 6. So when x is 7, y is 6. Okay, you should use 3. So if I plug in a 3, 3 minus 3 plus 4, That's 0 plus 4, which is 4. So 3 and 4. All right. Now here's my question. Can I go below 3? Can I put a 2 in there? If I put a 2 in there, that's going to lead me to a what? It would be negative. So I can't put a 2 in there. So it's telling me that 3 is really the last thing I can do. All right. So from this right here, I would, and I know it's a square, so I'm just going a graph that looks like that right there. So if you all can go back to August, what does that, if we go back to August, what does that minus 3 right here mean? What does that mean to do? Lesson 1.1. Good, Caitlin. Go to the right 3. And what is the plus 4 on the outside? What does the plus 4 on the outside tell us to do? Go up 4. So from our parent function, which does this right here, 0, 0, 1, 1, 4, 2, and then 3, 9, or 9, 3, sorry. That's our parent function. So here's what we've done with our parent. We've gone right 3. 1, we go right 3 because it's on the inside. 1, 2, 3, and we go up 4 because it's on the outside. 1, 2, 3, 4. That, and then I leave that same parent function. Look, I go up 1, right 1, up 2, right 4, up 1, right 1, up 2, right 4. Same process that we've done before. Thumbs up on that. All right, cool. Now looking at number 4. Okay, so number 4, the same thing here, but this is going to be our what? Our cubing function, correct? So with our cubing function, it can be negative. Okay, so it can come over here. We know what the parent function looks like based on this right here. It looks something like that. So it's going to have that same kind of thing here. But the difference here is it actually has a 2 there. Let's erase that 2 for right now. I want everybody just to kind of erase that 2. Yeah, Abby, I actually like that. Let's go back to 3 and let's find domain and range. Okay. Let's find the domain, and the homework may not say this, but let's go ahead and do it. So I think I'm at U, Elizabeth Woods. Tell me what the domain is And then while she's getting that, Maddie Burris, you get the range. Good, Elizabeth. Domain is from 3 to infinity. Maddie, good. The range is from 4 to infinity. With a bracket on 4 because it is included. It's a part of it. Very good. All right, so now let's step over here. And let's go ahead and erase 2. And the reason I say that is I'd rather do a problem like this, a little bit different before we go there. So the cube root of x plus 4. So let's just go ahead and make a XY table for it. Give me an x value, Lucy. No, Caitlin, I'm sorry. Caitlin and Lucy, give me an x value. Caitlin gave me 1. Lucy, give me something that's a cleaner one. Give me something that 2. No, there's not a perfect cube root of x. There. Okay, yeah. Give me a second. I'll try to see if we can straighten it out. Okay, so let's try that. So I think someone came over with a 8. And then, of course, we could go 27. So when x is 1, the cube root of 1 is 1. 1 plus 4 is 5. Cube root of 8 is 2. 2 plus 4 is 6. 27, which we really don't have on our graph. So let's go, oh yeah, 0. Let's not forget 0. So let's skip 27. 0 would be 4. So we got 0, 4. We got 1, 5. And 8, 6. Oh, yeah, 8. Okay. And then as some of you guys are spitting out, let's go negative. So if we go negative 1 plus 4, what is negative 1 plus 4 going to give us? 3. So negative 1, 3. And then if we go negative 8, what would that give us? The cube root of negative 8 -2. -2 plus 4 is 2. So it should be looking something like this. So it goes out. And then Dom and Josiah. Dom, you got a domain and you have range. Josiah, just type those in. Good job, guys. -infinity to infinity. -infinity to infinity. Very good. So, Abby, to actually answer your question, will those domain range always be the same? It will be for the cube root, but obviously it could change depending on where this would be. But over here, it should always be -infinity to infinity. All right, give me a thumbs up in regard to if we're good to go to the backside. Thank you, thank you, thank you, thank you. And hey, if you notice what I just did, I ripped that off, so you're okay if you want to rip that off. And then you can staple everything, once we get through everything. Yep, that's perfect, Abby, if you just want to put it in your binder. All right, so looking at rational functions, there is going to be a kind of typical form. They're in the form of f of x is equal to a times x minus h plus k. A determines vertical Yeah, that's an n in the that's an n in the root. Determines vertical compression and stretch, or vertical stretch and compression. H determines horizontal translation. And K determines vertical. Ooh, boy, I butchered that. Determines vertical compression. Excuse me, vertical translation. Okay, so just these last four and then we'll be done. So identify the domain and range of each, then sketch the graph. All right, so I'm looking at number 5. Let's first start with our main point. Okay, that main point, we know this is going to be a graph going to the right. So if we're looking at the main point of this graph, no, Elizabeth. Oh, well, actually, yes, Elizabeth. You tell me what would determine it. Go back to like chapter 1 and think about what determined horizontal. Yeah, if it was inside impacting X. Okay. So probably won't see much of that here. All right. So what I'm going to encourage you to do first is to take care of the other. Yeah, it would have to be inside the radical in order for that to be messed with there. So it'd have to be like inside here, like the square root of 1/2 x, and that would get really nasty pretty quick. So, all right. So looking at number 5, let me make sure the video is looking good. Okay. So what I want you to do first is take care of the -1 and the -2. I know this graph goes to the right, so -2 from my parent function goes down 2, and -1 on the inside goes right 1. So I'm going to go ahead and put a point there. That just took care of this and this. Okay. Now, if you think about what the normal radical x is doing, when you look at your x and y's of just radical x, it's 0, 0, 1, 1, and then 2, 8. Or excuse me. I'm sorry, I'm thinking of cube. 4 and 2. Okay. So again, go back here and notice what we were doing here. We went from the point, we went up 1, right 1. So up 1, right 1. Then we went from the point up 2, right 4. Easy, Rocket. Right, chill. Sorry, that was the dog. He saw a bird in the backyard. And then if we wanted to go again, it would be up 3 and right 9. Please, Christina. Hey, Rocket, easy. Pico boys. Now, just to jog your memory a little bit, when we had x squared, we had the graph that went 0, 0, up 1, right 1, right 2, up 1, 2, 3, 4. But when we had 2x squared, what did we do? We went right 1 and up how many? Right 1 and up 2. So it messed with our y coordinate. Yeah, very good. It doubled the y. So back here on this back side, again, if we're following this right here, up 1, right 1, up 2, right 4, we should kind of know how that's going to impact this, number 5. Okay? So if what we do is go right 1 and up 1, technically we need to do what here? Go right 1 and up how many? 2. Good. So right 1 and up 2. Then I want to go what? Again, if it's right 1 up 1 and then it's right 4 up 2, here it'd go right 4. Sorry, it'd go right 4, 1, 2, 3, 4, and up how many? Up 4. Are you good, Christina? And again, another way to think about that is to say, okay, if this is my point, that has taken care of. Yeah, and I'll explain. Let me explain again. So if we all understand how we're getting -1, that's right 1 down 2. That's how we get there. Then we're just left with this right here. Okay. And if I plug in a 1 there, 2 times radical 1, that's 2 times 1, that is equal to 2. So if I go right 1, I go up 2. If I plug in the next radical would be 4. If I plug in a radical 4 is 2. 2 times 2 is 4. So I'd go right 4, 1, 2, 3, 4, and up 4. 1, 2, 3, 4. Correct, Elena. Yep, correct. That takes you right back to it's almost like resetting it, and you just do everything from there. But this, you have a 2 in front of it, so that kind of restricts that. Yes, Abby. Use it for the X and the Y. And what we just need to know is that you just need to know, again, if you remember how much I stress knowing, like on X squared, right 1 up 1, right 2 up 4. We need to know the same thing here. Right 1 up 1, right 4 up 2. But obviously we double the Y each time. And if we look at this on the calculator, given that upward thing, yeah, you can always email me if you have questions later. Abby, can you do just another point even if it's not on the graph? Yes, you can do another point if it's not on the graph. So like the next point we'd want to use is like 2, and then radical 9 would be the next one. So that's 2 times 3. So that's 6. So that means I go right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and go up 6. 1, 2, 3, 4, 5, 6. So it's giving me that shape here that I have. If you have your calculator, if you went to your table, you would even see like how everything's kind of being backed up within that. Yeah, I would always, well, you're forced to use the same X values, Josiah. You're kind of forced to do that there just because it's the square root. So your X values are probably always going to be the same. So that's that. But to answer your question, I always go right back here, Abby. So from here, I know the graph goes right 1 and up 1, and then right 4 and up 2. But since that 2 is there this time, I got to go right 1, but then I got to multiply that y value, which is 1 times 2, and go up 2. Normally, I go right 4 and up 2, but I have to multiply that y value times 2. So 2 times 2 is 4, so I go up 4. I'd normally go right 9 and up 3, but I have to double that y value. Instead of being 3, it'd be 6. And that's what's taking me there. Now, something that I want you to always keep in mind, this is kind of the shortcut behind it. But if you don't know how to do any of this, just simply make a what? Half of you literally said it out loud. We just make an XY table. Okay? All right. So let's jump over to number 6. Y equals 2 times the quantity, the cube root of x minus 4 plus 3. So if I go back to the front side, notice what this front side was doing here. From the origin point, it goes right 1. Yeah, oh yeah, I'll get that domain. Right 1, up 1. And then right 8, up 2. All right. Here, and then likewise, it went left 1, down 1. And then left 8, down 8. Okay. So we kind of know that. That's going to help us on this one. And I keep forgetting. That's why you guys are here. I keep forgetting that we got to do the domain and range of each of these graphs. So what I just went over, that will help us with this. Well, let's come back over here. How about it? Yeah, down 2. Sorry. So give me the domains. Elena, you take care of the domain, and Kristen, you take care of the range. Good, Elena. 1 to infinity. Good, Elena. The range -2 to infinity. Very good, guys. Okay. So now, as I said down 8 while ago, I meant down 2 here. Sorry about that. So we need to kind of know the pattern of this to kind of get us going on the other side. Okay. So, and I don't know how much room we have here in the graph, but we can kind of but we will kind of work it out. So looking at number 6, let's take care of the -4 and the +3. What does that do? Can you tell me, Abby? Abby, what does the -4 on the inside and the +3 on the outside? What does it want us to do from the origin? Right 4, up 3. Good. Right 4, up 1, 2, 3. Good. Now again, the whole cube root of x normally goes up 1, or excuse me, let me go x direction first. Right 1, up 1. Right 8, up 2. So instead of going right 1, because we've taken care of this now, instead of going right 1 and up 1, I'm going to go right 1 and up what, Christina? Good. Go up right 1 and up 2. And that's because that 2 is there. So we just double this y coordinate each time. Then I would go right 8, but I can't go right 8 because I'd be way off the graph. So let's not worry about that. But let's go the other way. Normally I would go left 1, down 1, and left, and then left 8, down 2. But now I need to go left 1 and down how many? Left 1 and down how many? How about it, Bernice? Left 1 and Maddie helped out a little bit. Down 2, good. And then I can go left 8 from our origin point. Left 8, 1, 2, 3, 4, 5, 6, 7, 8, and down how many, Elizabeth Woods? Good, Elizabeth. And then down 4. 1, 2, 3, 4. Okay. So then that's going to lead us to a graph looking something like this. It goes up, it turns here, and then it goes up that way. Here, it's going down there, coming out like that. I actually went the wrong direction on that. Sorry, it would go more like that. It's more the snake. Sorry about that, not that. And then here it would be on the graph. Obviously, we're a little bit more zoomed in than what they are. Yeah. Thumbs up, smiley face if this is kind of coming together? Hey, great question, Maddie. It's always going to turn at that origin point. It's always going to turn right here. In calculus, we would call that concavity. This is where it changes from holding water to losing water. So it would be right there at that point. Good question. All right, going on to number 7. I'm joking. Let's do domain and range before Abby has a heart attack. So domain, let's see. Maddie, you got domain. Caitlin, you have range. Good question. While you guys are doing that, so how you do a cube root on the calculator was the question. You just hit math, Lucy. Oh, sorry. Let me scoot up just a little bit. You just hit the math button, which is located right below alpha. Hit math. And then it's the 4th one down. So you just hit 4, and then that gives you the cube root. Okay. And I saw some answers come in. Caitlin with the domain, or no, Caitlin with the range, and then obviously they're going to be the same here. Making sense? Okay. So, let's look at number 7. So looking at number 7, man, I feel like I'm off balance here. Okay. It's driving me insane. I feel like we're in a hole. All right, so here we go. Let's take care of the -1 to +3. So I need to go right 1, up 3. I don't think that mess with it. Y'all want to see Rocket? I'll show you guys Rocket real quick. Rocket, it's your boys. Come on, boys. Rocket. Oh, there he is. Hey, buddies. Come here, boys. It's your boys. Sit. 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 Good boys. Good boys. He's a good boys. Sit. Oh, good boys. Good boys. All right. All right, back over here. Looking at number 7. So we've taken care of right 1 and up 3. So I've taken care of that. Taking care of that. All right. Now, normally a square function goes right 1, up 1. Right 1, up 1. And then it goes right 4, up 2. Okay. It's doing that scaly thing again. Sorry, guys. So if it goes, normally from this point, I would go right 1 and up 1. But it's not just the regular square root of x. I need to multiply the y by 3/4. So if I use my calculator and I just say 1 times 3/4, I'm going to get 1 times 0.75. I'm going to get 3/4. Okay. So I need to go right 1 from here and up not quite to the next point. We okay with that? And then from there, I need to go right 4, 1, 2, 3, 4, and then up whatever 2 times 3/4 is. And 2 times 3/4, double 3/4 is 1.5. Look at you, Elena. 1, 2, 3, 4, up 1.5. So we should get the graph looking something like that. So with, again, you're just multiplying whatever's on the outside times that. Okay. And again, we can verify with the calculator. That's what we're kind of working with there. Okay. Can I go? My only issue is I can't really go. The only issue is I can't really go right 9 there and then up. Yeah, I will actually spend some time answering questions on the homework during the next live. Yes, I will. But we haven't even got to the homework yet, Abby. It's not going to be that bad. Okay, so domain and range. That would be Lucy. Lucy, you got domain. Dominic, you have range. Lucy says 1 to infinity. Dominic says 3 to infinity. I agree with both of you. Okay. Hey, I'm going to give you 3 minutes. I want you to work number 8 right now without my help. Don't be sitting there eating ice cream. Just work number 8 real quick without my help, and then I'll work it, and we can kind of see where we're at there. Give me smiley face if you're working on it. Let's go. Thank you, Maddie, for working on it. Christina, who's in your profile picture? Is that you? Imagine that. Elena's already done. How old are you, Christina? Like 10? What is Lucy trying to say? That's Ner with ice cream? Oh, so like 2 years ago, you were like 8, huh? If I'm making Elena and Abby laugh, I'm in good shape, people. I'm in good shape. I'm going to make it on my comedian tour when I retire from teaching. Josiah, you got any goldfish? Caitlin, why can't I do more than one thing? Can I not be an auctioneer and a comedian? Oh, yeah, yeah. Now you're talking, Abby. A comedian auctioneer. $1 down, $2 down, $3 down, $4 down, $5 down, $6 down, 7. I'm ready. Is there a way I can kick Christina out of the live group? Is that possible? Anybody help me with that? That's because it's lagging, Elena. My gosh. Oh, okay. I will report her. All right. So here we go. Last problem. Lucy, you better watch Spelling Renaissance. All right. So here we go. Go right one, up one. Okay. Now, normally from this spot, okay, with a cubing function, if you look up here, we would go right one, up one. But we have to multiply the y coordinate by 3. So I got to go right 1 and up 3. 1, 2, 3. Normally I go right 8 and up 2, but I need to go right 8 and up 6. Right 8. 1, 1, 2, 3, 4, 5, 6, 7, 8, and up 6. So it should be somewhere here. Normally I'd go left 1 and down 1, but I need to go left 1 and down 3. 1, 2, 3. Normally I'd go left 8. 1, 2, 3, 4, 5, 6, 7, 8, and down 2, but I need to go down 6 since there's a 3 on the outside. Okay? Now, Maddie asked a good question. How do we know where it turns? It turns right here at this point. So this should look like it's going out and then coming up to clip that. This should be going down and coming to hit that. Should look something like that. I'll check it real quick on the calculator. Make sure we're somewhat close. Okay. All right. So questions of me. Yes, we will have a test when we get. No. You will have a test over chapter 5 while we're on break right now. Okay, give me thumbs up or hey, I got it. Just to make sure we're all good. Good. I will answer Josiah's question. How do we turn in homework? You are not turning anything into me. Okay. Here's what you need to do. You need to put everything in your binder, just like you were at school. Here's number 7. Whoever asked that, you don't turn anything in, not yet, at least. Okay. So here's what I want. When we come back to school on April 14th, if we come back to school then, I want you to, then at that point, you're going to turn all this into me, notes and homework. Show me that you completed everything. Okay. And then I'll grade it from there. If that's not the case, if we do not come back to school on the 14th, I will reach out to you when that decision is made that we won't be, and I will tell you exactly how to turn it in. So don't worry about taking pictures and sending it to me or anything like that. I care more about your understanding. I think everyone in this class is mature enough to handle me just saying, hey, get your stuff done. I want you to understand it more than we're concerned about a grade. Okay. Your grade will come if you're actually doing the work. So that is that. The test, yes, it will be online. I'll try to make it the process pretty simple. And I haven't nailed it down exactly how I'll give it, and because obviously it's almost impossible to keep people from cheating. But again, it's about your understanding more than anything. But we'll create some way. I answered Josiah's question. I answered Caitlin's question. I put number 7 back up for Lucy. Any other questions of me? All right. So again, your goal for tomorrow, just knock out 5.3 homework. Okay. Knock out 5.3. And I will take questions over it on whatever day it is, Thursday when we do live again. Hey, another thing, as you see, we've been on here for an hour and a half. I don't know if you can see that or not. That's going to be typical, guys, just because this is not your normal, class setting. And if you think about it, we actually did take sometimes 2 days to do a lecture. That's why we're only meeting most weeks twice. Sometimes we'll meet 3 times, but most of the time we'll just meet twice. So then you can kind of see it. If we're Maddie, to answer your question, you don't, technically speaking, you don't have to do the homework today. I would work on it between sometime today and Thursday, but I'm not going to check it until we get back to school. But don't be that dumb kid that waits. And I know, obviously, Matt, I'm not talking to you, but don't be that kid that says, oh, I'll do it, I'll eventually get to it. And then next thing we know, we have, you have 30 things to do, and tomorrow, oh, we're going back to school. And don't bank on us not going back to school as a excuse for you to not do it, because then I will have you turn it in, and it will have to be due like that day. So you won't have time to do it if you're banking on, oh, we're not going to go back to school. Good questions. Any other questions of me? And as I was saying, plan to be on here an hour and a half, almost 2 hours every single time we meet, and that can kind of justify us. If you think about it, if we're missing school for 3 weeks, meeting two times a week for an hour and a half, 2 hours is nothing compared to you doing that. Hopefully, this is this good with everybody in terms of did it come through well? Are you seeing it? Is this a good idea, or should we think about doing something else? Okay. Thank you. Yeah. Okay. Cool. Okay. Cool beans. And I don't want you to think I'm fishing for compliments as much as I am. It's pretty important that we get through some of this stuff, and I understand the precaution and safety of us not being in school. So I understand both ways. Yeah, good question. It won't necessarily be at 2 every single or every other day or every single day for the next 3 weeks because I have other classes that I'm teaching. So sometimes like I'll teach, it just depends on what I'm teaching that day because I'm doing YouTube live with the regular algebra 2 and my AP calculus as well. So that would just depend on what those times are. I got to spread them out due to the length of them. So sometimes, it may be at 2, sometimes it may be at 11 a.m., it may be at 9 a.m. You'll have that schedule a week. I'll give it to you every single Sunday. I'll send you that schedule. Sunday night or Sunday afternoon, I'll send you the schedule of what it will be that week. I know a lot of you work, so I know you're wondering like right now, hey, can you go ahead and send us the schedule? But obviously the schedule could change just based on how things go with the class if something goes wrong or something like that. So I'll try to send it to you every Sunday. But if you do miss, again, I want you here because again, you can ask questions live. So that's the power of being live instead of just a recorded one. But you can always go back and watch these videos again. Next question. All right. I'm going to hang out in here for a little bit. So if you want to let some people like fall off the stream and then you ask me a question, that's completely fine. If you want me to review anything else on the notes, like, hey, I didn't really get that, just hang out a little bit and a lot of people will go off. No, my kids actually have work. They use Class Dojo, and they send them like video, and they tell them basically they send them a big packet home, and they send them a video each day, like saying, "Hey, do this, do this, do this, do that." So yeah, they are still working. See you, Abby. Good day. You are free to leave if you want to leave. I know you're bored out of your mind, so if obviously you can stay here. So, um, I'm not sure if you can or not. I'm not sure if you can go to the restroom or not. Good day, Lizzie Adams, whoever you are. Good day, Maddie Burris. Keep swimming. Actually, stay out of the water. Maybe contaminated. Good day, Kristen. That's actually pretty good, Caitlin. Maybe I should just eat salad in here tomorrow. Good day, Bernice. Good day, Christina. Good day, Caitlin Gibson. If anybody has any other questions, just let me know. I'm going to cut the live stream at an hour 41. Twitch, are you still on here? Twitch is gone.